tachometer is used to measure. Okay, tachometer ni use chesi మనం ఏం మెజర్ చేస్తాము, కరెంట్, ఫ్రీక్వెన్సీ, వోల్టేజ్ ఆర్ స్పీడ్. ఓకే, tachometer ని యూజ్ చేసి మనం స్పీడ్ ని మెజర్ చేస్తాం, స్పీడ్. ఓకే, ఆప్షన్ డి ఇస్ ద కరెక్ట్ ఆన్సర్. ఓకే, అలాగే కరెంట్ కెన్ బి మెజర్డ్ బై యూజింగ్ ammeter. ఓకే, అలాగే వోల్టేజ్ కెన్ బి మెజర్డ్ బై యూజింగ్ voltmeter. ఓకే, అలాగే ఫ్రీక్వెన్సీ కెన్ బి మెజర్డ్ బై యూజింగ్ వేవ్ మీటర్ ఆర్ వెయిన్స్ బ్రిడ్జ్. వేవ్ మీటర్ అండ్ వెయిన్స్ బ్రిడ్జ్. ఓకే, tachometer is used to measure speed. Okay, next question. If number of turns in a coil are doubled, okay, number of turns are doubled, then inductance will be, okay, 4 times, 2 times, 1/4 or half. Okay, we have one formula for inductance. L is equal to mu n square A by L. Okay, from here we will get L is directly proportional to n square. Okay, inductance is directly proportional to square of the turns. Okay, we can also write L2 by L1 is equal to N2 square by N1 square. Okay, L2 is equal to, okay, N2 number of turns are doubled. Okay, N2 is 2n. Okay, 2n whole square by n square into L1. L2 is equal to 4n square by n square into L1. n square will cancel. L2 is equal to 4L1. Okay, inductance will be 4 times of initial inductance. Okay, 4 times. Option A is the correct answer. If number of turns are doubled, the inductance will become 4 times. Okay, next question. The electrical current is analogous to magnetic circuit. Okay, electric circuit la electric current అనేది దేనికి రిలేటెడ్, magnetic circuit la. Okay, electric circuit, here magnetic circuit. Okay, in electric circuit current is similar to flux in magnetic circuit. Alage here EMF in electric circuit is similar to MMF, magneto-motive force, MMF in magnetic circuits. Okay, alage resistance in electric circuit is similar to reluctance in magnetic circuit. Okay, alage conductance in electric circuit is similar to permeance in magnetic circuit. In the question they are asking electric current is similar to flux. Okay, from the options, option A is the correct answer. Okay, next question. According to the Steinmetz hysteresis law, the hysteresis loss of material is directly proportional to, okay, hysteresis loss is directly proportional to, okay, Bm power 1.2, Bm power 1.6, Bm power 2 or Bm power 2.6. okay, hysteresis loss. Hysteresis loss is directly proportional to Bm power 1.6. okay, alage eddy current loss is directly proportional to Bm square. Okay, here in the question they are asking eddy current loss is directly proportional to Bm power 1.6. option B is the correct answer. Okay, next question. Which one of the value inductance of coil that induces 20 volts when current through the coil changes from 12 amperes to 20 amperes in 2 seconds? Okay, we have to find inductance value. Okay, inductance value we have to find. Voltage is given, current is given and time is given. Okay, we have one formula, V is equal to L di by dt. Okay, L we have to find L value. Okay, V is given, V is 20 volts. L we have to find current, change in current 12 to 20 amperes. Okay, 20 minus 12 by time is 2 seconds. Okay, now 20 is equal to L into 8 by 2. Okay, 2 1 ja 2 4 ja 8. Okay, 4 1 ja 4 5 ja 20. Okay, L is equal to 5 Henry. Okay, from the options, option D is the correct answer. Okay, next question. If the coefficient of coupling is K is equal to 1, then coils are said to be. Okay, coefficient of coupling. Okay, coefficient of coupling K అనేది range అనేది 0 to 1 ఉంటుంది. ఓకే, మనకి maximum value K max is equal to 1. Okay, under which condition? Okay, when two coils are tightly coupled. When two coils are tightly coupled, then K value is 1. Okay, K value is 1 under tightly coupled condition. Okay, next question. A DC shunt generator supplies 15 amperes to the load. Okay, at 220 volts terminal voltage, the shunt resistance will be 220 ohms. The armature current will be. Okay, we have to find armature current. DC shunt generator. Okay, I will draw the DC shunt generator diagram. This is DC shunt generator. Okay, this is DC shunt winding, shunt field winding having resistance of 220 ohms. Okay, this is armature having resistance of RA and EMF EG. Okay, terminal voltage is given. Terminal voltage is 220 volts. 220 volts. Okay, now the current supplied to load is 15 amperes. This is 15 amperes. Okay, okay, next current through the field winding. Same here, terminal voltage 220 volts is applied across field winding. Okay, here we will get ISH is equal to V by RSH. Okay, V is 220 by 220 is equal to 1 ampere. Okay, ISH is equal to 1 ampere. Now we have to find armature current IA. Okay, IA is equal to IL, load current, into shunt field current. Okay, IA, armature current is equal to load current plus shunt field current. Okay, load current is 15 amperes, shunt field current is 1 ampere. 15 plus 1 16 amperes. Okay, armature current is 16 amperes. Okay, from the options, option D is the correct answer. Okay, next question. The EMF generated in DC generator is directly proportional to. Okay, EG is directly proportional to flux per pole or speed of the armature, number of poles, or all of the above. Okay, we have equation for generated EMF. EG is equal to pi Z N by 60 into P by A. Okay, pi Z N by 60 into P by A. Okay, here EG is directly proportional to flux per pole. This is flux per pole. Okay, alage EG is directly proportional to number of the conductors. Okay, alage EG is directly proportional to speed. EG is directly proportional to number of poles, and EG is inversely proportional to number of parallel paths. Here directly proportional to flux per pole. This is right. Alage EG is directly proportional to speed of the armature. Yes, speed of the armature. Okay, alage number of poles. Okay, this is also correct. Okay, answer is all of the above. D, option D is the correct answer. Okay, next question. Wave winding is employed in DC machine for. Okay, wave winding అనేది మనకి ఎందుకు యూజ్ చేస్తాం? హై కరెంట్ అండ్ లో వోల్టేజ్ అప్లికేషన్స్, ఆర్ లో కరెంట్ అండ్ హై వోల్టేజ్ రేటింగ్, ఆర్ హై కరెంట్ అండ్ హై వోల్టేజ్, ఆర్ లో కరెంట్ అండ్ లో వోల్టేజ్, ఆర్ ఆల్ ఆఫ్ ది అబోవ్. ఓకే, మనకి డీసీ మిషన్స్ లో 2 types ఆఫ్ వైండింగ్స్ ఉంటాయి. వన్ ఈజ్ ల్యాప్ వైండింగ్, సెకండ్ వన్ ఈజ్ వేవ్ వైండింగ్. ఓకే, మనం ల్యాప్ వైండింగ్ వచ్చేసి హై కరెంట్ అండ్ లో వోల్టేజ్ అప్లికేషన్స్కి యూజ్ చేస్తాము. అలాగే వేవ్ వైండింగ్ వచ్చేసి హై వోల్టేజ్ అండ్ లో కరెంట్ అప్లికేషన్స్కి యూజ్ చేస్తాము. ఓకే, ల్యాప్ అండ్ వేవ్ వైండింగ్. ఓకే, ల్యాప్ వైండింగ్ వచ్చేసి మనం హై కరెంట్ అండ్ లో వోల్టేజ్ అప్లికేషన్స్కి యూజ్ చేస్తాం. అలాగే వేవ్ వైండింగ్ వచ్చేసి హై వోల్టేజ్ and low current applications ki use chestam. Here in lap winding number of parallel paths is equal to number of poles. Alage wave winding lo number of parallel paths is equal to always 2. Okay, here wave winding is used for high voltage and low current. Okay, from the options, option B is the correct answer, low current and high voltage. Okay, option B is the correct answer. Okay, next question. A 240 volt DC shunt motor draws a current of 15 amperes. Okay, the resistance of shunt field will be 150 ohms and the resistance of armature will be 0.2 ohms. What will be the armature current? Okay, DC shunt motor. Okay, I will draw the DC shunt motor diagram. This is field winding, shunt field winding. This is armature having armature resistance of 0.2 ohm. Okay, the terminal voltage is 240 volts. 240 volts. Okay, next shunt field resistance RSH is equal to 150 ohm. 150 ohm. Okay, and the line current is 15 amperes. 15 amperes. Okay, now shunt field current, what ISH is equal to V, same V, terminal voltage is applied across field winding. Okay, ISH is equal to V by RSH. Okay, V is 240 by RSH is 150. Okay, 150. Okay, 0 0 will cancel. 3 8 ja, 3 5 ja, 8 by 5. 8 by 5 is equal to 1.6. Okay, 1.6 amperes. Okay, ISH is equal to 1.6 amperes. Okay, now we have to find armature current. Armature current IA is equal to load current, line current minus shunt field current. Okay, armature current is equal to line current minus shunt field current. Okay, line current is 15 amperes. 15 minus 1.6 is equal to 13.4 amperes. Okay, from the options, option B is the correct answer. Okay, next question. A 6-pole wave connected armature has 300 conductors and runs at 1000 rpm. Find the EMF generated if the useful flux per pole is 0.04 webers. Okay, we have to find generated EMF. Okay, we have formula for generated EMF. EG is equal to pi Zn by 60 into P by A. Okay, EG is equal to pi Zn by 60 into P by A. Okay, pi Zn by 60 into P by A. Pi is the flux per pole. Flux per pole is 0.04. 0.04. Z is number of conductors 300. Okay, speed is 1000 rpm. Okay, by 60 into P, number of poles is 6. Okay, A is number of parallel paths. Here wave winding la always parallel paths is 2. Okay, 6 by 2. Okay, here 6 1 ja, 6 10 ja. Okay, 0 will cancel. Okay, 2 1 ja, 2, 0.02. Okay, we will get 0.02 into 300 into 100. Okay, we will get 100. 0.02, we will get 600 volts. Okay, 0.002 into 300 into 100, we will get 600 volts. Okay, from the options, option C is the correct answer. Okay, next question. A 200 volts DC shunt motor takes a total current of 101 amperes at full load. Okay, the field and armature resistance are 200 ohms and 0.2 ohms respectively. What is the total copper loss? Okay, we have to find total copper loss. Okay, total copper loss is equal to armature current IA square, armature copper loss IA square RA plus shunt field current losses. Okay, shunt field copper losses ISH square into RSH. Okay, now we have to find armature current and shunt field current. Okay, I will redraw the circuit. RSH this is EG, this is RA, okay. The terminal voltage is 200 volts, 200 volts, okay. అలాగే షంట్ ఫీల్డ్ రెసిస్టెన్స్ RSH is equal to 200 ohms, okay. Now షంట్ ఫీల్డ్ కరెంట్ ISH, here 200 volts is applied across షంట్ ఫీల్డ్, okay. Same ISH is equal to V by RSH, okay. V is 200 by 200 ohms is equal to 1 amperes. ISH is equal to 1 ampere, okay. Now armature current, okay. Here total current is 101 amperes, okay. 101 amperes. From 101 amperes, here 1 ampere is going, okay. Here armature current is 100 amperes, okay. Armature current IA is equal to IL minus ISH, okay. IL line current is 101 amperes, okay, minus ISH is 1 ampere is equal to 100 amperes is the armature current, okay. Now we have to find copper loss, okay. PCU, copper loss is equal to IA square. IA square means armature current is 100 amperes, 100 square into armature resistance is 0.2 plus ISH is 1 square plus 200 ohms. We will get here 2000 plus 200, okay. Total copper losses is equal to 2200 watts, okay. From the options, option D is the correct answer, okay. Next question. A full load transformer has 800 watt copper loss, okay. Then find the loss at off load, okay. Full load copper loss is 800, okay. We have to find off load copper losses, okay. P copper loss at X load is equal to X square into P copper losses at full load, okay. Here X is the load, okay. X is here 1 by 2 half of the load, okay. Substitute here, okay. X square 1 by 2 whole square. Copper loss at full load is 800 is equal to 800 by 4 is equal to 200 watts, okay. 200 watts, okay. 200 watts is the copper loss at off load, okay. Option C is the correct answer, okay. Next question. If the copper loss at full load of transformer is 400 watts, calculate the copper loss at off load, okay. Full load copper loss at X load is equal to X square into copper loss at full load, okay. Here X is 1 by 2 square. Copper loss at full load is 400 watts, 400, okay. 400 by 4 is equal to 100 watts, okay. From the options, option D is the correct answer, okay. Next question. Considering the induced current to be negligible, okay, the equivalent resistance referred to primary, okay. Equivalent resistance referred to primary of transformer, primary side of transformer, okay. Here this is transformer, number of turns is N1, this is N2, okay. This is R01, okay. R01 is the equivalent resistance referred to primary side, okay. R01 is equal to R1 plus R2 dash, okay. R2 dash is equal to R2 into N1 by N2 whole square, okay. Substitute here. R01 is equal to R1 plus R2 into N1 by N2 whole square, okay. This is the equivalent resistance referred to primary side, okay. R01 is equal to R1 plus R2 into N1 by N2 whole square, okay. R1 plus N1 by N2 whole square into R2, okay. This is option is D is the correct answer, okay. Next question. The condition for maximum efficiency in transformer, okay. Condition for maximum efficiency. Copper loss is equal to 0 or core loss is equal to 0 or copper loss is equal to core losses, okay. Condition for maximum efficiency, okay. Condition for maximum efficiency వచ్చేసి copper loss is equal to iron losses or copper loss is equal to core losses, okay. Next question. Open circuit test on transformer is conducted to determine, okay. మన open circuit test మన transformer లో కండక్ట్ చేసి ఏం డిటర్మైన్ చేస్తాము, hysteresis loss or copper loss or core loss or eddy current loss, okay. Open circuit test ఓపెన్ సర్క్యూట్ టెస్ట్ వల్ల మనం ఐరన్ లాస్ అనేది డిటర్మైన్ చేస్తాము. ఐరన్ లాస్ ఆర్ వీ కెన్ ఆల్సో కాల్ కోర్ లాస్. ఓకే. అలాగే షార్ట్ సర్క్యూట్ టెస్ట్ కండక్ట్ చేసి మనం కాపర్ లాస్ని డిటర్మైన్ చేస్తాము. కాపర్ లాస్. ఓకే. హియర్ ఇన్ ద క్వశ్చన్ దే ఆర్ ఆస్కింగ్ ఓపెన్ సర్క్యూట్ని కండక్ట్ చేసి కోర్ లాసెస్ని డిటర్మైన్ చేస్తాము. ఓకే. ఆప్షన్ సి ఈజ్ ద కరెక్ట్ ఆన్సర్. ఓకే. నెక్స్ట్ క్వశ్చన్, విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ మెథడ్ ఈజ్ నాట్ స్పీడ్ కంట్రోల్ మెథడ్ ఫర్ ఇండక్షన్ మోటార్. ఓకే. ఇచ్చిన ఈ 4 ఆప్షన్లో మనకి స్పీడ్ కంట్రోల్ మెథడ్ కానిది ఏంటి? ఓకే. ఫస్ట్ స్టేటర్ వోల్టేజ్ కంట్రోల్. ఓకే, దిస్ ఈజ్ వన్ ఆఫ్ ది స్పీడ్ కంట్రోల్ మెథడ్. ఫ్రీక్వెన్సీ కంట్రోల్ ఈజ్ ఆల్సో వన్ ఆఫ్ ది స్పీడ్ కంట్రోల్ మెథడ్. ఓకే. రోటర్ రెసిస్టెన్స్ control. Okay, rotor resistance control is also one of the speed control method, but stator resistance control is not a speed control method. Option C is the correct answer. Okay. Next question, how to calculate slip percentage in 3-phase AC motor? Okay, slip formula. Okay, slip is equal to synchronous speed minus rotor speed by synchronous speed into 100%. Okay, that is slip percentage. Okay, ns minus nr by ns into 100. Okay, from the options, option D is the correct answer. ns minus nr by ns into 100. Okay. Next question, for a 3-phase induction motor, the value of the slip if the motor is not running. Okay, motor not running. Okay, means nr is equal to 0. Okay, if motor is not running means, okay, nr is equal to 0. Okay, now we have to find slip is equal to ns minus nr by ns. Okay, here nr is equal to 0 means ns by ns is equal to ns will cancel, is equal to 1. Slip is 1. Okay, if motor is not running, the slip will be 1. Okay, option C is the correct answer. Okay. Next question, one hydro alternator has 20 poles and rotates at 3300 rpm, then what is the frequency? Okay, here number of poles and the speed is given, we have to find frequency. Okay, we have the formula for frequency f is equal to p n by 120. Okay, p is number of poles is 20, speed is 3300 by 120. Okay, now 21 ja 26 ja 6. Okay, 6 5 ja 30, 550. Okay, frequency is 550 hertz. Option C is the correct answer. Okay. Next question, what is the complete formula for frequency? Okay, what is the formula for frequency? Okay, frequency is equal to p ns by 120. Okay, number of poles into synchronous speed by 120. Okay, from the options, option D is the correct answer. Okay. Next question, the speed of 6-pole 60 Hz alternator is, okay, number of poles and frequency is given. Now we have to find speed of alternator. Okay, alternator speed. Okay, alternator always runs at synchronous speed, we have to find synchronous speed. ns is equal to 120 f by p, 120 f by p. Okay, here 120, frequency is 60 hertz by p, number of poles is 6. Okay, 6 1 ja 6 10 ja. Okay, 120 into 10 is equal to 1200 rpm. Okay, from the options, option B is the correct answer. Okay. Next question, if the efficiency of LED is 80 lumens per watt, okay, then what will be the output of lamp, okay, of 20 watt LED? Okay, the power rating is given and also efficiency is given, we have to find the output of light. Okay, we know the formula for efficiency is equal to luminous flux by input power. Okay, efficiency, that is luminous efficiency is equal to, okay, luminous efficiency is equal to luminous flux by input power. Okay, efficiency is 80 lumen per watt. Okay, now luminous flux, we have to find luminous flux. Okay, in lumens. Okay, Now input power is 20 watts, 20 watts. Okay, now luminous flux is equal to 80 into 20 is equal to 1600 lumens, 1600 lumens. Okay, from the options, option C is the correct answer. Okay, 1600 lumens. Okay, next question. The resistance of 230 volts 100 watt incandescent bulb is, okay, here voltage rating is given and power rating is given. Now we have to find resistance. Okay, we have relationship between resistance, voltage and power. That is power P is equal to V square by R. Okay, V square by R. Okay, power rating is given and voltage rating is given. We have to find resistance. Okay, R is equal to V square by P. Okay, R is equal to V square. Okay, 230 into 230, 230 into 230 by P. P is equal to 100. Okay, here 0 0 will cancel. 23 into 23 is equal to 529. Okay, 529 ohms, 529 ohms. Okay, from the options, option B is the correct answer. Okay.